with 4.4 being multi-step equations. Multi just means more than one. So our two objectives, I can solve equations that require distribution and combining like terms. That's stuff that we do before we get to use principles of equality, because after we're done with this stuff, once we get there, then we will force values to become zeros and ones like the starter problem, right? So we have to do this first, and then we can do this stuff. If we're going to solve a multi-step equation, there are these first two steps, which we saw in the objective, but right now we're just going to focus on 3 and 4. If we can isolate the variable, which means we want to get it by itself. Usually it'll be x, but it could be other letters as well. If we can just get the letter by itself on its own side of the equal sign, then we can force the coefficient to be a 1, which means that when we say isolate the variable, that means we're usually going to be making zeros in this step. And then, of course, the last step here, we're going to force the coefficient to be a 1. Now, it's possible we may only need to make one of the terms a 0, sometimes 2. I can't think of a case where we would need 3. But we'll make zeros, and then we make 1s. So it is usually in this order. So addition and subtraction, principles of equality, is where we make zeros. And again, the reason why we want to make zeros is because we don't have to look at them. We get to ignore those completely. And yes, this is what we will do in this process. We'll do this first. Once we get to the point where we need to isolate variables, we're going to make zeros, and then after that, then we will make 1s. Now, if we can understand which values we need to make zeros, which values we need to make 1s, that's pretty good. To go back to what we saw last time, if I see a coefficient that is not a 1, coefficient, just like we saw in the starter problem, then I will force it to be a 1. But I have to use these two operations to do it. I would not want to use addition or subtraction to make a 1, because then we would still be adding a 1 or something to a variable, or subtracting, which doesn't help us. So really, this third part right here, and what we'll find is that it even works for all three of these. These three are meant to simplify, which we've seen. So we're going to be looking to simplify the expression. Like I said, we'll look at 1 and 2 here after we do a few examples. But for now, let's just focus on creating zeros, making zeros, and then making a 1. With this, it's a little bit bigger than the problems that we saw last time. But we'll see that it's just a matter of making zeros and 1s. Now, like we saw on that last slide, the first thing I want to do is isolate the variable. So I want to get the variable by itself. The variable, in this case, is x. So what I would notice here is that I would like the x to be by itself. It is not by itself, and I'm not talking about the negative 5. That's negative 5x term. It's the plus 8 that I can't have there. Meaning, what I really want to be able to do is take that negative 5x, and I'd like to just be able to drop it down here. Like this. And then, once I do some kind of principle of equality here, it should just read negative 5x equals something. Well, that means that I can't have this plus 8 right there. And since it's an addition operation, addition and subtraction mean that we're going to zero it out, which also means that we can ignore it. So I will do that. I will take that plus 8 and subtract 8 in order to make a 0. But if I do it to one side, I must do it to the other side as well. Now, if I were to look at this, I see that I have dropped my negative 5x's. I now have 8 minus 8, which is 0. That was part of the plan. And then on the right side of the equal sign, I've got 33 minus 8, so I'll make that 13 minus 8, which is 5. And then the 2 will drop. So now I have an equation showing negative 5x equals 25. And that did isolate the x's, or it got the x's by themselves. All negative 5 of them. Now, it becomes like a problem like the starter problem, meaning that it's like if we had started with this problem right here, kind of looks like the starter problem. But we had to do some work to get to this point, and that was okay. We just had to zero out a value. But now what I'm going to do is I'm going to make that coefficient of x a 1. So we'll make it a 1 by taking -5 coefficient and dividing it by itself. That's the division principle of equality, which is meant to make ones, which we just did. But if I do it to one side, I need to make sure I do it to the other side. So now, on the right side, 25 divided by -5. How many times does 5 go into... Well, I guess first I should say it's negative, because we have a negative and a positive. How many times does 5 go into 25? 5 times. Now, this -5 came from the division. It has nothing necessarily to do with this one. But that's pretty much it. Now, the last thing I'm going to do here is just check, right? So I'm going to go back to my original equation, -5x plus 8. And remember, that's supposed to be a solution. The 1x equals -5 should be a solution. So that means that -5x plus 8 needs to equal 33. Now, I don't know if it does if I take the x and if I were to replace it with -5. But I'm going to find out. So -5 times -5 is 25. Now I got 25 plus 8 equals 33. By the way, this 25 right here comes from this 25 right there. So it's kind of like we worked down through this, from this original equation, we worked down. Now we're going to work back down, or it's kind of like working our way back up. Depends on how you want to look at it. Well, 25 plus 8 is going to be 33, which does equal 33. This last time I checked. That right there is true. Now we know we have found the solution. And it is a solution because it makes the original equation from here. Once we replace the x with -5, we did some math and found that the equal sign is a true statement. Okay. So the first thing I need to do is isolate that 6y. Now, it's not actually 6y. It's -6y because of the minus sign. So we'll have to keep that in mind. Right? Because as I work with this, so I am looking for a principle of equality. I would like to just take that -6y and just drop it so that it's all by itself. The problem is I got this 5 right here, and I can't just be like, well, I'm going to ignore that 5, which, I mean, that'd be convenient. I just can't do it. So I've got to get rid of that 5. And by get rid of, since it's being operated on with either addition or subtraction, that means we need to zero it out. So I will be subtracting 5. Correct, yep. So 5 minus 5, that will zero that out. But on the other side, I'm going to have to subtract 5 there. Now, I'd like to do this from left to right, right? So we got 5 minus 5. That zeroes out, as was the plan. And then I'll drop the -6y, which we've done already. And this would equal -43 minus 5, which is going to make it more negative. Then I can take 43 and add 5 to see exactly how negative it will be. 3 plus 5 is 8. And then we'll drop the 4. So it ends up being -48 right there. So what we just did right there, that isolated the y's, which was pretty much the whole point right there. They're on their own side of the equal sign. We got all the numbers on their own side of the equal sign. But the problem now is that the coefficient of y is a -6. We need it to be a +1. +1y equals something. So how do I make that -6 coefficient a +1? Simply take it and divide it by itself. But if you do it on one side, you must do it to the other side as well. -6 divided by -6 is 1. On the right side, I've got a negative divided by a negative, which is a positive. 2 negatives make a positive. 48 divided by 6 is 8. Boom. Now that should work. Again, I'm just going to do a quick check in the original equation. 5 minus 6y equals -43. And we should see the -48 and then finally the -43 as we go through this. So if I were to do that, I would be checking with the y value, that is 8. Not completely sure that this is going to be true. But we can see here that I would show this as -6 times 8, which is -48. So now I've got 5 minus 48 should equal -43. And then, yeah, this one, I'm going to skip some of the work there, but that's going to be -43. So -43 does equal -43. That's true. And since it is true, that means we did in fact find the solution. So negative 6 minus w equals 4. So yeah, principle of equality here. I like that negative w, and it is a negative w. In fact, I'm going to show it as a negative 1 once we get to that point. But I don't want that negative 6 with it, so I'm going to isolate it by adding 6. If I do it to one side, I got to do it to the other side. Negative 6 plus 6 is 0. We've already dropped the negative w, and this would equal 4 plus 6, which is 10. Now here, yeah, the problem is we've got a negative 1w, but we don't want negative 1w as our final answer. We want 1w instead. So we're going to take that negative 1 and divide it by itself in order to make the coefficient a positive 1. Yep, if I do it to one side, I got to do the other side. Now a positive divided by negative makes a negative. Anything divided by 1 is itself, negative 10. So in checking though, negative 6 minus negative 10 minus a negative makes that plus 10. Negative 6 plus 10, there's more positives than negatives. 10 minus 6 is 4. Boom. We found the solution. So we will solve it. And the first thing I got here, and this one's a little different because now the variable they're used, and also they're on the right side of the equal sign. Doesn't matter. Principles of equality will still apply. So we're going to make a 0 first. Why are we going to make a 0? Because with the u's, whatever this looks like, and I've got 2u thirds, 2u over 3, I got the minus 8 right there. So since I have minus, and I would like to take that 2u thirds, or 2u over 3, and just make it by itself, I can't have the minus or negative 8 with it. So that means I would have to add 8 to both sides. Oh, I still messed it up. Well, that's okay. We'll make it work. All right. All right, so here's what happens. I've got 9 plus 8. I go from left to right. 9 plus 8 is going to be 17. We already dropped the 2u thirds. And negative 8 plus 8, 0. So that isolates our u's. You know, it's going to be kind of jacked up because I didn't choose very good numbers, but that's okay. We can still work with it. Now, there's two different directions you can go right here. I'm going to need 2 more principles of equality because I've got division and I have multiplication. So I'm going to stick with that, even though there's a different way to do it, but I don't want to confuse anyone. So I'm going to keep it like this. So what I would like out of this, and I'm going to get rid of division first because we hate division. Although you could get rid of the multiplication as well. So the 2u over 3, I would multiply by 3 in order to make the 3 divided by 3 a 1. But if I do it to one side, I got to do it to the other side. In fact, that times 3 on the left, I'm going to show it like this one. Okay, so what happens? I got 17 times 3. 7 times 3 is 21. Carry the 2. 3 times 1 is 3, but adding the 2 makes 5. So 51 equals, we had the 3 divided by 3, which now became a, I'm going to call that a phantom one, because I'm not actually looking at it any longer. The next thing I need is for the coefficient of u to be a 1. I want this to be 1 u's, not 2 u's. So I'm going to take the 2 u's and split them in half, so divide by 2. If I do that to one side, I must do it to the other side. And at this point, I'm going to show the division on the left as a fraction line instead, because I don't really, well, we haven't gone over the decimal unit. This as a fraction, even though I wasn't really expecting any fractional answers. So if that fraction could be simplified, I would. It could be changed into a mixed number, not that I really care about it, but if you want it, it'd be 25 and 1/2. Either one of these works. Now, if you were to check this in the original answer, it should work, meaning it should be the solution. I guess I can kind of verify that. So 2u, 2 times 51 halves would be 51. Then we'd have 51 over 3, which is 17. And then 17 minus 8 is 9. Yeah, so that works. So we did, in fact, find the solution. Now, with that, though, I'm going to show a different way to look at this. And if that made sense, you can ignore what I'm doing. Once we got to that point, I'm going to take this equation where we had 17 equals 2u over 3, but I'm going to show it as 2/3 u instead. Now, the reason I'm doing that is because then I've got only one multiplication with u, and I can get rid of a fraction. I can make a fraction of 1. And I can make a fraction of 1 simply by taking it and dividing it by itself. Because at this point, what I would like is just a regular 1u, just like we have in our answer. But if I were to do that, I would have to take 2/3 and simply divide it by itself. So anything divided by itself is 1, including fractions or decimals, negatives, positives. And if I do that to one side, I would have to do it to the other side. So I'd show 17 divided by 2/3 there. Now to divide a fraction, we don't really like that, so I would change that to multiplication. So that'd be 17, but now I would change the operation to multiplication and flip the fraction into 3/2. Well, now we've got fraction multiplication, so I'll make that 17 over 1. And our multiplication, 17 times 3, we've already done, is 51. 1 times 2 in the denominator is 2. So we get the same answer either way. I don't know which one is more work, but it works. It ends up working the same. Okay, so we see the same slide, but now it's showing you got these first two steps, which, we'll expect to see some of this on the assignment. But again, we really look at this and we say, well, look, the first three parts here is all just a matter of simplifying. Simplifying the equation. So we've done this before, distribution, which is just another way to say multiply. Once we multiply, with parentheses, by the way, then we will combine any like terms that we may have on either side of the equal sign. So I can't, just like we've been seeing, and we haven't said this specifically, but isolating the variable is how we combine like terms across the equal sign. So we can only combine like terms on one side of the equal sign and then the other side of the equal sign if it's needed. And combining like terms means that we are looking specifically at either addition or subtraction. Isolating the variable, which is the addition or subtraction principles of equality, that's these two that we use in order to make zeros. Just like we've seen already, and then multiplication and division. That's how we make ones, but not just any ones. We're looking to make coefficients ones. That's it. So this goes back the first two steps: distribution, combining like terms. I think that was 4.2 kind of stuff. Maybe a little bit of 4.1 stuff. We're going to see it. We have to do that stuff first in order to simplify. And then once we see where the variables are, then we can start to zero things out and then make a 1. So I would look at this one and I would think I've got to do distribution first. Okay, so distribution first, then combining like terms. The problem is some students look at this and they're like, there is no distribution, but there is. Multiplication is distribution. Pretty much if I ever see any sets of parentheses, I am expecting some form of distribution. Now, when I show the parentheses there in red, some students say, well, I got to distribute the 20. The 20, you got subtraction between the 20 and that -5. So the number that I'm actually looking at is a -1. There's a phantom 1 there the whole time. So it's -1 times -5. And if you want to show the individual distribution rainbow, then feel free to do that. But I now have negative times a negative, which is going to make a positive. And 1 times 5, anything times 1 is itself, including 5. So now, the equation shows something like this. And I just can't emphasize this enough. This is a very common error. And you see how, there's only like 5 terms here. But this one individual error, if we don't do this in the beginning, it tends to mess everything else up. So just be careful. All right, next up, what I would like to do is, and it's important to know where that equal sign is. So I've kind of just brought it down right here, just so I don't mix up combining like terms on either side. Because I can't combine across the equal sign unless I'm going to use principle of equality, which I need to combine like terms first. Combine like terms. Do we even have any like terms? On the left side we do. I've got 6x's minus 9x's, so that'd be 6 minus 9. That means I'm subtracting more than I have, so I should end up in the negatives. And then you just take the big number and subtract the small number. 9 minus 6 is 3. So that's how negative the x's are. I've got negative 3x's. We also got that plus 7 right there, so nothing to do with that. No other constants to combine there with the positive 7. But on the right side, I do have a 20 plus 5, which would be 25. So if you need to add that, feel free to do it. 0 plus 5 is 5, drop the 2. So that completes distribution on the first line, and then the second line, we combined like terms. All right, we got this equation, and kind of wrote it a little weird, but it's doable. So I can ignore all the stuff that I just barely did, although I like to see it. And I see I've got negative 3x plus 7 and equals 25. So there's no like terms that I can combine anymore on either side of the equal sign. So that means I'm at the point where I'm going to need principles of equality to isolate the x's. And I'm talking specifically about the negative 3x's. I'd like to be able to just drop it and see what it equals. But the problem is this plus 7, there's plus. Since it's an addition of 7, and I need to zero it out, but we should also know that it needs to be zeroed out because of the addition. So if we see addition or subtraction, we need to zero it out. And that means that I would have to subtract 7. If I do it to one side, I must do it to the other side. So the negative 3x drops. This was part of our master plan to make this a 0. And then on the right side, I'd make that 15 minus 7, which is 8, and then drop the 1. Or, it just means we got the variable by itself. Now, we need to make that coefficient of x. It's a negative 3 right now, but we need it to be a positive 1x. 1x equals something, and that will complete the problem other than checking. So, how do we make that negative 3 1? Simply divide it by itself. But if you do it to one side, make sure to do it the other side too. So negative 3 divided by negative 3 is 1. Here I got a positive divided by negative, so my answer will be a negative. And 18 divided by 3 is 6. We did it. Now, just for the sake of time and space, because I'm out of space there, but this would be 6 times, well, I guess I'll kind of show the work there a little bit. So I got to go back to the top, and I would replace the x's with the negative 6 that we found, right? So that'd be 6 times negative 6. That's going to be positive 36 right there. And then the negative 9 times negative 6 be positive 54. So it'd be like 36. That should be negative 36 because it's a positive times a negative. Negative 36 plus 7 would be negative 29, plus 54 is going to be 25. And I'm skipping some work there, but we already did the 20 minus negative 5, which was 25. So that was equal. That's true. So we do have a solution down here at the bottom. Now that's a little bit different way to show the work for checking, but hopefully you have more time and space to do that. There's the equation. You tell me what to do. Boom. All right, now I'm going to check real quick just to make sure that it is an actual solution, right? So that'd be 9 times negative 1. And if you were to calculate that, it'd be negative 9. Now I would read that as negative 8 times negative 1, which would be positive 8 and then plus 6. Well, if you were to combine that, negative 9 plus 8 is negative 1. Plus 6 would be 5, which does actually equal 5. That's true, which means we did in fact find the solution. So it is common for students to look at a problem like this one and just be like, you know what, I'll lose the points for this problem. But the truth is, you got to be a little patient And if you can remember that really what we're going to do is break this up into smaller, more manageable parts, then it doesn't, in my opinion, it doesn't become that bad. So, of course, the first part that we're going to look at is distribution. And there's two sets of parentheses, which means we have two sets of distribution, that set of parentheses and this one. And distribution is multiplication. Now, a common mistake, which we've seen already, is where students distribute this and they're like, well, that's 6 times x, which is, it's fair enough, that's 6x, and then they'll say, well, there's the minus sign. It's not that it's 6x, it's negative 6x, because we're distributing this negative 6. The minus sign makes the 6 a negative, which means over here, and this is where the mistake really occurs, is students would do 6 times 6 to get 36, but again, it should be a negative 6 times positive 6, which is negative 36. Why is this 6 positive? Because of the plus sign. Well, that brings us to the next set of distribution. So that would be, again, multiplication. I'll even show the phantom 1 right there. So that would be 2 times 1x's, which would end up being 2x's. And then the next distribution or multiplication is going to be 2 times 1, which is going to be positive 2. Okay, that is all the distribution that I see, so everything else just drops, right? I got 8 minus 6x minus 36 plus 5x equals 6. That 2x was positive, so I'll show the plus sign, plus 2 minus 3. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. 8 terms. But the good news is, with those 8 terms, now that we have all the distribution complete, we will look to combine like terms. So again, it is large. It's 8 terms. But we're going to only focus on as many terms as we need to at a time to combine like terms. Such as, just to start out, I'm going to start on the left. I like to go from left to right. Not that you have to. But I would show 8 and negative 36. So that's going to be 8 minus, I would show 8 minus 36. I'm subtracting more than I have, so I know I'm going to end up with a negative. Then I would take the big number and subtract the small number. So 6 minus 16 minus 8 would be 8. And then drop the 2, so that's going to be negative 28. That's how negative it became. But in addition to that, we also have these x's that we can combine as well. So how many x's is that? That's negative 6 plus 5. So they are opposite signs. There's more negatives than positives, so I'm expecting an answer that is a negative. Then I can just do 6 minus 5, which is 1. So it's a negative 1x right there. That's all the combining like terms that I can do on the left. There were 4 terms, 2 different types of terms, so we end up with 2 different types of terms on the left side as well. On the right side, we have 3 constants, and that's okay. I've got a 6 plus 2 minus 3. So I would do 6 plus 2, which is 8, and then minus 3, which is 5. And then the positive 2x, it just drops. I mean, that is quite a bit of work right there. But again, if you focus on one part at a time, combining your constants, combining your x's, then we combine constants, and then we just drop the 2x's, then it's going pretty well. The problem here, and this is new for us, is I have x's on both sides of the equal sign, which is new. I also have constants on both sides of the equal sign, and that's okay too. But we did all the distribution and we did all the combining like terms, which means we're at the point where we need principles of equality. At this point, what I like to do is to decide which side I want my x's on and which side I want my constants on. I am going to choose to put the x's on the left, and then I will put all the constants and numbers on the right. So I put the x there and then the number sign there, not hashtag, that's different. My generation, that was a number sign. But negative 28. Okay, so I'm going to go through all the terms and see if they're on the correct side. If they are not on the correct side, then I will zero it out. Okay, so I start with negative 28. Okay, so I got the dividing line here, not for division, but to separate. Negative 28 is on the x side of the line. It doesn't have an x, so it can't be there, meaning that I need to zero it out. So I'm going to add 28 there. and I know that will zero out. But on the right side, I'm going to have to add 28. Here's what you wouldn't want to do is put the plus 28 right here, because then it looks like you're going to combine it with the x term. So we purposely look at that plus 28, and we add it to the other constant, the 5. All right, now again, working from left to right, negative 28 plus 28 is 0. I can then drop my negative 1x, which is going to equal, that's going to be 5 plus 28. 5 plus 8 is 13, carry the 1. 1 plus 2 is 3. So I got 33 there, and then I got the positive 2x, which I drop again. Okay, now I still got x's on the left, numbers on the right, but my x, the negative 1x, that's okay. It's on the x side. So I don't need to do anything with that. It doesn't need to be zeroed out. Going further to the right, 33 is on the number side because I crossed the equal sign. So 33 is on the number side. It's okay as well. So I'm going to leave that alone. But the 2x has an x, but it's on the number side. It's on the wrong side. Since it is on the wrong side, that means that I do need to zero it out. Well, can we zero out x's? As it turns out, we can. Simply by taking the 2 x's and subtracting 2 more x's. Like this. Just take something and add its opposite or subtract it from itself, and you will zero that out. But if I do it to one side, I must do it to the other side as well. All right, so from left to right, let's see what happens here. I got x's. That's negative 1 minus 2. So it's going to become more negative. And then I do 1 plus 2. And that's how negative it is. 3. Negative 3 x's. I've got the 33 here on the other side, which I do need to drop. And then the 2x, what do you know? They zeroed out, just as we had planned. So everything has gone according to plan. We've distributed. We've combined like terms. And you got to be careful. Again, I'm going to go back to the distribution part right here. But if you did not distribute a negative 6, you would have gotten plus 36, which is going to jack the whole thing up, which we don't want to do. So we did the combining like terms. We made a 0. We made another 0. Now we're ready pretty much for the final step, which is to make that coefficient of x a phantom 1. 1x. Well, I'm getting not a phantom 1, just a regular 1. You could make it a phantom 1. Okay, so it's a negative 3x. How do I make it a 1? Just divide it by itself, negative 3. If you do it to one side, you must do it to the other side. There's my 1x. 33 divided by negative 3, positive divided by negative is going to make a negative. 33 divided by 3 is 11. Negative 11 should do it. Okay, so that's what we got. I'm going to go back to the top and just kind of double check the work. Not just the work, but I'm going to check in the equation. So at the top, I'd say this is this right here, negative 11 plus 6. That'd be negative 5 times the negative 6 there. That'd be a positive 30 plus the 8 would be 38. And then that'd be a minus 55. 38 minus 55, negative 17. Of course, I'm skipping some work there, but then we got negative 11 plus 1 is negative 10. Times 2 is negative 20. I'll write that in. So 6 minus 20 would be negative 14. Minus 3 is negative 17. So that is true. Since it is true, we did find the solution. All right, so first up, we do have parentheses for some distribution. And we're distributing a negative 3. So we'll start by multiplying, which is distribution. The negative 3 times a 1x, which is x's. Negative 3 times 1 is going to be negative. 3 times 1 is 3. That's the first distribution. Now the second distribution, negative 3 times 9. So negative times positive is a negative. 3 times 9 is 27. There's that. Now we've got 3 minus 3x's minus 27 plus 2x's equals 8 minus 4. And that's all the distribution we have. So we're going to look now to combine any like terms that we have, such as 3 and negative 27. So that would be 3 minus 27. So we're taking away a lot more than we have, so it's going to be negative. Take the big number minus the small number. 7 minus 3 is 4. Drop the 2. Negative 24. Then the x's. Now, how many x's do we end up with? Well, that's negative 3 x's plus 2 x's. And since we're adding opposites and there's more negatives than positive, it's going to be negative. And then we'll do big minus small. 3 minus 2 is 1. Negative 1 x's. Okay, this would equal, on the right side, we have 8 minus 4, which is 4. So from here, we did all the distribution, and then we did all the combining like terms, which means that we're at principles of equality. I've already got my x's on the left, all of them, and I'll need to put all my numbers on the right. Negative 24, I do not want with that negative 1x. So I'm going to have to add 24. If I do it to one side, I must do it to the other side as well. So that's going to zero that out. We drop the negative 1x's, which equals 4 plus 4 is 8, and then drop the 2. So that's 28. The last thing we want is a coefficient of x that's a positive 1. And that should solve it. So to make that negative 1 coefficient a positive 1, we'll divide it by itself on both sides. That makes a 1x. Positive divided by negative is going to make a negative. 28 divided by 1 is 28. So our solution ends up being negative 28. So yeah, the other method is with that fraction. So at this point, I probably, and you can show it however you want, but I would multiply this side by 6 and this side by 6 to make that a phantom 1. Now I've got negative 8 x's equals, so this was 96. And then dividing both sides by negative 8, we get 1x equals negative 12. Same answer, different method. That's it. So again, distribution first, combining like terms, make your zeros, make your 1, you're done.